So examples 3 and 4 here. So this graph shows the height of the tide, h meters, as a function of time, t, at Port Clements and Haida Gwaii on June 17th, 2009. Here we have our graph, nicely titled. We've got labels on our axes with units. We've got a scale. We've got some points plotted and our graph drawn. And then we ask ourselves, well, here's our question A. So identify the dependent and independent variable of this function or relation and justify your choices. So this is where you make those statements or that statement. Does the height of the tide depend on the time of day, or does the time of day depend on the height of the tide? And from those two statements, you should be able to logically think, well, the height of the tide depends on the time of day. So height is our dependent variable. Time is our independent variable. Okay? Independent variable is our horizontal axis. Dependent variable is our vertical axis. Or eventually we'll be calling these x and y when we get into like regular equations. So there's your dependent and independent variables. Why are the points in the graph connected? Well, if we look at the points on our graph here, well, we know that these points are right on the hour. But can we measure, you think to yourself, can we measure the height of the tide at, well, this is 9, 10, 11, 12, 1. This would be 9:30. Can I take a measurement of what the tide would be at 9:30? Absolutely. And that would correspond to some height. So because I can measure all the individual points between there, then I can draw a line. If I can't do that, then I wouldn't draw a line, I would just have individual points. So why are all the points connected? All the points are connected because the tide is not restricted to any particular whole number values. Okay. Height of tide. Whoops, I spelled that wrong. Height of tide is not restricted to whole numbers. Question C. Oops, erase. Question C. Determine the domain and range. So domain, remember, are x values, or our horizontal values in this case, or our independent values. What's our lowest possible value? Well, that's 9 o'clock. What's our highest possible value? 1, 2, 3, 4 o'clock. Or by the clock that they were measured, it was 9 o'clock less than equal to, I'm going to call it t because it was time, not x. And this is my domain. And it's going to be less than equal to 13, 14, 15, 1600. And my range, what's my lowest range value? This value right here would be, what is that, 8.8, 0.10, 0.81, so it's going to be 0.9, 0.9, 0.9, 0.9, less than equal to my height, less than equal to, this is my range, and my highest value, whatever this is right here, 1.2, 1.4, 1.5. 0.5. And there's your domain and range. Over the page. Now we can start applying this to real equations. So not real equations, just normal everyday equations that we would come across as real work. Example 4. Here's a graph of the function g of x is equal to 4x minus 3. Remember, this is function notation. This is just a fancy way of saying y is equal to 4x minus 3. Okay, but we can do a little bit more with function notation. Determine the range value when the domain value is 6. Range value when the domain value is 6. So remember, the domain values are our horizontal axis values, in this case, which is our x values. So this is asking, what's the range value when x is equal to 3? So I take my function notation equation, g of x is equal to 4x minus 3. whoops, 4, forgot the x. 4x minus 3, and I want to find g of 3. So I substitute in 3 for x, and I calculate g of 3 is equal to 12 minus 3, or g of 3 is equal to 9. Okay. Or another way I could do that is just read it from the graph. Well, if I'm looking for an x value of 3, which is right in here, where does that cross the graph? Well, right about there. Follow that over, and I get pretty much 9. So I could read it from the graph as well. Determine the domain value when the range value is -7. Again, so reading from the graph, -7 is going to be here somewhere. Over to the edge of the graph, where it touches the graph, back up. It should be somewhere like -1. But I can use my function notation equation. G of x is equal to 4x minus 3. This time, while this is -7, is equal to 4x minus 3. Add 3, -4 is equal to 4x minus 3, or sorry, 4x. Divide by 4, divide by 4. Well, -4 divided by 4 is -1, and that's exactly what I just got. So there's playing around a little bit with function notation. You could ask domain and range for this question. Quick question there. Domain and range for this relation would be, dun, dun, dun. The domain would be all real numbers, and the range would be all real numbers, because you can assume these don't have arrows on, or they have arrows on them. There's no end point noted. There's no circle, there's no dot, so it continues on forever. So the domain, both x values, and the range, y values, would be all real numbers. So both the domain and range, all real numbers. You could also ask yourself this question, well, is this relation a function? And then you'd simply try that vertical line test. Is there a place where I can draw a vertical line through 2 points on that graph? And in this case, there isn't, so this would be a function as well. Questions noted at the bottom of the page here. Good luck with the assignment, and remember, practice, practice, practice.